Hey guys, hope everybody's doing okay. In this video, I'm going to show you how to create a global slope stability app in Google Earth Engine. We'll start off by taking a look at the app, and then we'll go over some slope stability basics, and then we'll dive into the code. So here's our app. You can see we're fully zoomed out, and we've got some global imagery in the map window. We've got a panel on the right side of the screen with a title, some instructions, a legend, and some references at the bottom. The instructions tell us to draw a shape with the polygon or rectangle tool up here around the area that we're interested in, and then click go. When we click go, the map zooms into whatever shape we drew and shows us a nice slope stability surface that's been clipped to the shape that we drew. We can zoom in and see some unstable slopes in red and orange, and then we can see some stabler slopes in green and some water in blue. Can zoom out and do this again. Say we want to do it over here. And click go again. And we'll zoom into a new area with a new clip slope stability surface. So we can think about slope stability in terms of driving forces versus resisting forces. Resisting forces are kind of the things that keep a material on a slope. Two of the most important resisting forces are internal friction and cohesion. Internal friction is basically a material's ability to hold itself together, and cohesion represents the force of roots and soil moisture from vegetation kind of holding soil together. Driving forces are the forces that pull material downslope. Two most important driving forces are gravity and water saturation. Gravity is pretty self-explanatory, and water saturation reduces the friction between material and the slope itself and sort of aids flow. Google Earth Engine hosts global rain, land cover, and elevation data, so we can use these data sets to estimate water saturation, cohesion, and slope. So we'll focus on these variables for our stability analysis. So we'll weight all of these variables from 0 to 1. So we'll add all of these reclassified variables up, we'll weight them, and that'll give us our slope stability surface. Now we can get into the code. Here's our code window. You can see a bunch of imports that we've got at the top here. We'll need to import the SRTM 30 meter digital elevation data, Copernicus land cover data, global land cover layers, and world climb biovariables 1 climate data. And the rest of these imports are visual parameters for all of our different layers. So starting at the top here, these two lines of code zoom the map out all the way so you can see the whole world and make the base map satellite imagery instead of this map that we have here. So we'll start with land cover data, and we use this dot first code because we can only remap a single image, and Copernicus land cover is an image collection. So this dot first code gives us a single image that we can use. And this dot select command chooses one band, the discrete classification band from the land cover raster. Next, we'll set up our precipitation data. So this variable rain is one band, bio 12 band of our world climb data, and that's the precipitation band. For the DEM, we don't need to choose a band because it's already single band. So we can just use this ee.terrain.slope function to convert our elevation data into slope data. Next, we'll reclassify / remap our land cover data. And we'll do this while keeping in mind that heavily forested areas have a lot of vegetation and will keep very cohesive soils and stabler slopes barren areas don't have any roots to hold them together, so they're going to be a lot less stable. So this remap function in Google Earth Engine remaps raster values to whatever you want them to be. So you start with a list of raster values. So these are values given by Copernicus. We've all looked at that document when we were doing the human migrations assignment. So we've got this list of variables with all of the land cover values. And then after that, we've got this list of new values. So that 20 will turn into 0.7, that 30 will turn into 0.6, that 40 will turn into 0.6, so on and so forth. So now we've scaled this from 0 to 1, with 0 as our most stable and 1 as our least stable. And you'll see a couple zeros in our remap here, and those are for bodies of water and glaciers that we aren't really concerned with. Next, we'll jump into this function, which holds the rest of our code. And this will all play into our user interface code towards the end. So we'll start by opening up a function called clipMap. This line of code right here just resets all of our map layers at the beginning of the function, so we don't keep accumulating layers every time we try and use the app. This code is super important. This lets the user draw a polygon or a rectangle that will be used to clip our slope stability surface. So the map.drawing tools part of this makes drawing tools available to the user, lets them draw. This .get gets the first shape drawn by the user, and this .toGeometry converts that shape into usable geometry that we can use to clip everything. So we'll use this clipper variable to clip all of our map layers to the user's created geometry. So these next two lines of code weight our land cover and clip it to the user's polygon, and then add it to the map. These next two lines of code normalize our slope data from 0 to 1. Because this data is continuous and has a range from 0 to 90, we can just divide all of these values by 90 with the .divide function. So we'll also weight that a little heavier than the other two variables and clip it and add it to our map. These next two lines normalize precipitation data by dividing by the maximum value. We're also weighting our precipitation values, clipping them to our clipper, and adding that to the map. These next couple lines create our slope stability surface by adding our 3 weighted rasters and clipping it to our clipper, and then adding it to the map. The second to last line of code in our function centers our map on the user's drawn polygon and zooms to the extent of that polygon. This final line of code in our function erases that polygon that the user drew, so the user can use the app over and over and over again for different areas. And that's the end of our function. So now we're going to finish up the UI, and we'll start with the legend. And I copied a lot of this code from the example scripts in this left sidebar here in Google Earth Engine. Oops. So what I did, I just went to the top and I searched legend, and I got a bunch of different scripts that have all added legends, and a lot of them do it in different ways. So you can choose which way works best. And this was super helpful because I had no idea where to even start, and this gave me a great jumping off point. So this function generates a PNG of a color bar with 4 colors and these dimensions. And this code plugs our color ramp that we used for our slope stability surface into the color ramp function. And that'll spit out a color bar for us. And that's our variable color bar. These next couple of lines create minimum and maximum labels for our legend. And these will go on either side of our ramp. And we can do this by creating a little bit of a panel and specifying that we want our layout to be horizontal. So we'll have min on the left, color bar in the middle, and max on the right, instead of the usual top to bottom. These next couple of lines of code are just labels with our title and instructions. This next block of code creates a button with the word go on it in green. And when the user clicks that button, it runs our clip mat function that has all of our main code in it. And then we have some more labels with a description of the app and our data sources. And these last couple of lines of code put all of our UI stuff into one big panel on the right. And this final line adds that panel to our app.
Now we can run our code, and it'll spit out the app that we saw earlier. We can draw a little circle around something and run it. There we go. I'll put the app and the code and the slides in the Slack, and you can Slack me if you have any questions. Thanks.